Hi guys, today we're going to learn how to graph sine and cosine functions. So phenomena that repeat with a predictable pattern, such as tides, phases of the moon, hours of daylight, they can be modeled by sine and cosine functions. These functions are periodic because the same cycle keeps repeating over and over and over. So like you can see this normal heartbeat, if you were just laying in bed resting and had a resting pulse, your heartbeat would be pretty steady and it would keep repeating that same graph over and over. Same with the sun plus moon tidal force on the earth. We continually repeat the same rotation around the sun, which causes the tidal force to change on the earth in the same motion over and over and over again. So these are periodic functions. Now, periodic functions have lots of parts. The first one is called a cycle. And a cycle is something where it doesn't repeat at all. For instance, right here, the smallest part that doesn't repeat, you can see starts here at 0 and ends a little bit before 3/4 pi. That right there that's one cycle. Now the period is the length of one cycle. So in this case, the period starts here and goes to here. That's one period. After that, it's going to just keep repeating that hill over and over and over again. The midline is the place in the graph where half of the data is above and half of the data is below. So in this case, if I draw it in the midline, it would be like right in here. Half of the information is above that line and half of the information is below. That's the midline. And then finally the amplitude. And the amplitude is like the height or the distance between the midline and the maximum and the midline and the minimum. So in this case, if we start at the midline and go up to the maximum, this right here, this would be the amplitude. Okay, so let's try to graph a really basic function called y equals sine x. This is the basic sine function. So think back to the unit circle. At the unit circle at 0 radians, the coordinate is over 1 up 0. At pi over 2 or 90 degrees, the coordinate is over 0 up 1. At pi or 180 degrees, it's negative 1, 0. And down at 270, it is 0, negative 1. And then when you get back to 2 pi, it is back to 1, 0. So if we fill in the sine functions, remember sine is your y value. So if we fill in the sine functions, we're looking at what's the y value at 0? Well, the y value at 0 is 0. The y value at pi over 2 is 1. The y value at pi, or the sine value, is 0. The 3 pi over 2, the sine value is negative 1. And at 2 pi, we're back to 0. So if we graph these points, you can see the sine value would have a coordinate of 0, 0. We're going to go up to 1. Let's put 1 right here, which puts negative 1 down here. So then we're up here at positive 1 at pi over 2. At pi, we're back to 0. By 3 pi over 2, we're down here at negative 1, and then we're back to 0 at 2 pi. If you connect those, you want to connect them with a nice smooth curve. That's the beginning of the sine function. In fact, that's one cycle. The period is 2 pi because that's the length that it goes before it starts repeating again. After 2 pi, it's just going to repeat this pattern over and over again. I can also go backwards. So I can add in some of my points moving backwards into the other side of my graph. And that is a basic sine function. Now sine functions, remember, they measure the y values, which is going to be the vertical movements. The domain on here, it can go forever to the left and forever to the right. So it goes from negative infinity to infinity. The range is basically the y values. How far up and down does this thing go? Well, the lowest it goes is negative 1, and the highest it goes is positive 1, and it includes those two spots. And so it's going to go from negative 1 to 1, including negative 1 and 1. That's why I use those square brackets. The period, remember, the period starts here and ends here. After that, it's going to keep repeating the same pattern. Well, that period is 2 pi. The midline in this case goes right across here. Half of the graph is above that line, half is below. That's at y equals 0. So the midline is y equals 0. That's the equation at that midline. And then the amplitude is, in this case, 1. So if you start here at 0, from that midline it goes up to a highest value of 1 or down to -1. So the distance from the midline to the max or the midline to the minimum is 1. Second, remember the sine function actually started at 0 and went up towards 1 as it moved into the graph. So keep that in mind. That's going to be helpful. All right, let's try cosine. So think about your unit circle. This coordinate is 1, 0. This coordinate is 0, 1. This coordinate over here at pi is -1, 0. And down here is 0, -1. So if we think about cosine, cosine is your x value. So here our x value is 1 at 0 radians. At pi over 2, the x value is 0. At pi, it's -1. At 3 pi over 2, the x value is 0. And then at 2 pi, it is back to 1. So if you think about graphing these points, cosine gets a coordinate, or it gets a point at 0, 1, 0 radians. So let's make this 1, and then we'll make this -1. At pi over 2, it has a value of 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, it's 1. So you can see the cosine curve is starting to take shape. And we actually just graphed one cycle. And look at it, it started up here at 1, and by the time it got to 2 pi, it's back at 1, and it's going to repeat that shape. So let's go fill in the other side of our graph. Oops, I messed that up. Excuse me, I'm going to erase a little bit. Okay, so we got to get our dot here, and then our dot here. There we go. So there is our cosine function. Notice the cosine function starts up here at +1 and heads downward towards 0. If I go back for information to kind of memorize, cosine starts up here at 1 and heads down towards 0. Okay, the domain. It does go forever to the left and forever to the right. So that can be -infinity to infinity. The range is the y values. The lowest it gets is -1. The highest it gets is 1. And it does include those two values. The period is 2 pi. After 2 pi, between 0 and 2 pi, it's all new stuff. But then when you get to 2 pi, it's going to start repeating again. The midline is still at y equals 0. Half of the graph is above that line and half is below that line. So y equals 0 is the midline, and the amplitude is still 1. From the midline to the max is one unit, like from here to here, and from the midline to the min is also 1 unit. The cosine measures the x values, or in other words, the horizontal movements. All right, so this looks kind of tricky and complicated, and it kind of is. These are the more complicated versions of sine and cosine functions. And all of the different variables here do something to our graph. They're going to transform the graph in some way. Today we're just going to work with two of the variables. We're going to work with A. A is the amplitude. So we're going to change that amplitude today from 1 to other values. And we're also going to work with D, which is the midline. So instead of the midline always being at y equals 0, we're going to shift our graph up and down. And so amplitude, you can see here, it's going to be the absolute value of A. So whatever coefficient is in front of our function, whatever number is in the A spot, if we take the absolute value of that, that's going to give us our amplitude. Also, one other thing to note, if A is less than 0, it is going to make our whole graph reflect over the x-axis. D, the number in the back, or as you can see, sometimes it's floating out front, this D value is going to be the number that will translate or slide our whole graph up or down. Okay, let's jump in and try one. So you can see right here, we have y equals 3 sine x. So the transformation that is going to happen here, I can see a 3, which is going to, instead of our amplitude being 1, our amplitude is going to be 3. And so what's going to happen is we are going to have a vertical stretch by 3. The period is still going to be 2 pi. In fact, all of the functions that we graph today will have a period of 2 pi. The midline, you can see there's no d floating back here anywhere. There's no extra value floating back there. So the midline is going to continue to be at y equals 0. The amplitude, however, is going to be the absolute value of 3, which is 3. And now we're going to try to graph this function. Well, remember the sine values around the unit circle at 0 are 0, 1, 0, -1, and 0. These are the normal sine functions as you go around the unit circle. Well, for 3 sine x, what you're going to have to do is you're going to have to take those numbers and multiply by 3. 0 times 3 is 0. 1 times 3 is 3. 0, -3, and 0. So now you can plot those points. You're going to plot the top row and the bottom row. So we're still going to start at 0, 0. We're at pi over 2, though. We're going to be up at 3. So I think instead of going by halves, this time I'm going to count by ones. And so up here, I'm going to have a dot. At pi, we're back at 0. At 3 pi over 2, we're down at -3. And then we're back to 0. And so you can see the start of the graph looks very similar to the first one, except the amplitude has changed by a scale factor of 3. And so I'm going to finish off my graph here quick. And there it is. Y equals 3 sine x. Okay, let's try another one. So here we can see the cosine function has a -2 behind it. This is in the D spot. This is going to slide your whole function down 2. So it's going to have a shift down 2. It's going to translate it down. The period is still going to be 2 pi. That's the one cycle. And then the midline is still going to be at y equals 0. Oh, excuse me. No, it is not. The midline, we just said, is going to shift down 2. So our new midline is going to be at y equals -2. The amplitude, there's no number here in front of cosine. And so the amplitude is like the absolute value of 1. If nothing's there, it's like a 1 there. So that's still going to be 1. Okay, think of your normal cosine values. At 0 radians, the cosine is 1. Pi over 2, it's 0. Pi, it's -1. 3 pi over 2 is 0. And if you're back at 2 pi, it's 1 again. Now what we have to do is shift this down. So to get our new points for cosine x minus 2, we're going to have to take all of these values and subtract 2 from them. So 1 minus 2 is -1. -2, -3, -2, and -1. All right, let's try to graph this. So the midline has shifted down. It is going to be down here at y equals -2. I'm going to count by ones. So this is -1, this is -3, this is -4, and this is positive. You don't have to label every single spot, but label a few. Okay, so here we go. We're going to graph. So when x has 0 radians, our value is at -1. So we're going to put a dot. I'll graph it in blue. We're going to have a dot here. And then at pi over 2, we go to -2. And then at pi, we go to -3. And then at 3 pi over 2, we're back at -2. And then at 2 pi, we are at -1. So you can see it still looks like a sine curve. It starts above our midline by 1 unit, but it has shifted down 2 units below the axis. I'm going to finish off my graph here. And there it is. We have shifted our entire function down 2 units. All right, here we go. Let's try another one. So what is the transformation? So I can see the only thing that's really changed is there's a negative sign here. When there's a negative side in the in the amplitude, that means it's going to reflect over the x-axis. So the period will still be 2 pi. The midline will still be at y equals 0. The amplitude will still be the absolute value of 1 because the number in front of there is -1. Excuse me, -1, and the absolute value of that is 1. And now think of your sine values. At 0 radians, our sine is 0, then it's 1, then it's 0, then it's -1, then it's 0. Okay, but we want to know what happens if it's negative sine x. So what you're going to do is multiply all those values by -1. Okay, so let's see, 0 times -1 is still 0. This becomes -1, 0. This becomes positive, and this becomes 0. So if we graph our midline, it's going to be still at y equals 0. And then we're going to graph the top and bottom rows of our chart here. So sine is going to, at 0 radians, is going to be at 0. Then at pi over 2, we're going to be at -1. I'm going to count by halves. And then at pi, we're back at 0. And then at 3 pi over 2, we're at +1. And then we're back at 0 by 2 pi. So you can see this looks like a sine curve, but instead of starting at 0, 0 and going up, it's starting at 0, 0 and going down. It has reflected over the x-axis. I'm going to finish off my curve. And there it is. There is a sine curve that has reflected over the x-axis. Let's try another one. So here, there's many things that are going to take place. First of all, see this 3 out front? That is going to be like your D. This -2 is like your A. The D is kind of floating off by itself, its own term there. The -2 is the coefficient. The negative on the -2 is going to tell us to reflect over the x-axis. The 2 is going to tell us have a vertical stretch of 2, or by 2, scale factor of 2. And then that 3 is going to have a whole vertical shift. So we're going to shift up by 3 units. The period is still going to be 2 pi. The midline has shifted. We have shifted up 3, so it's going to be at y equals 3. And the amplitude has changed. We take the absolute value of -2, which is 2. Okay, so let's think about our values. For a normal cosine at 0 radians, it's 1, 0, -1, 0, and 1 as you go around the unit circle. But now we have 3 minus 2 cosine x. We have to have a few things happen here. So first thing we're going to have to do is we're going to have to multiply all of these values by -2. But then we also have to shift it up, so we're going to have to add 3 to each of those values. Now think of PEMDAS, do order of operations, do multiplying first. So 1 times -2 is -2, and then plus 3 is 1. 0 times -2 is still 0, and then add 3. -1 times -2 is 2, and then add 3. You get 5. 0 times -2 is 0, add 3. And 1 times -2 is -2, add 3, you get +1. So you can see our values are going to range from 1 to 5. So as I think about how I want to label my y-axis, I have to get up to a 5 at some point. And so I'm going to count by ones. Okay, so let's try to graph this. I'm going to go ahead and graph at 0 radians. My value is 1. So that's going to be here. The other thing I can do, just for good measure, is I can draw in my my midline. So my midline is going to go at y equals 3. Half of my graph should be above that. Half of my function should be above that, and half should be below. Okay, so first coordinate, x was 0, or radians were 0, and the value was 1. Now at pi over 2, my value is 3. At pi, my value is 5. At 3 pi over 2, I'm back to 3. And at 2 pi, I am back to 1. So if I connect those, and you connect them with like a curved line, not straight segments, you can see that is one cycle, or it expands a period of 0 to 2 pi, so 2 pi. Go ahead and fill in the other side of the graph, and you'll see 2 cycles. or you'll see the graph over a period of 4 pi. Cool. Let's go to the next. All right, this last example, you can try this one on your own. So go ahead and pause the video, try this one, and we can check in with each other and see if you got the same thing I did. Okay, so let's look at this last example. What our job is here is to match the graph with the function. And so, I don't know, maybe you could start with the midline. So I'm looking at A, for instance, and I see a midline. Half of the graph is above y equals 1, and half of the graph is below y equals 1. So it looks like it shifts up 1. Right away, this stood out to me. This has an amplitude of 2. Oh yeah, it does have an amplitude of 2, so this one must be A. Take a minute and try the other 3 on your own, see if you can figure them out, and then unpause it and I'll tell you what the answers are. Okay, so B, the midline is down here at y equals -3, so I know I have to shift down 3. Here's a -3 that is not a coefficient right in front of the function. It's kind of separated. That's going to be my shift down. So this is going to be B. Here my midline is y equals 0. It looks like I have an amplitude of 3. So at this point it still could be either number 1 or number 4. Does it look more like a cosine or a sine? That is the question. So it starts here at 0, 0, but instead of going up, it goes down. So it looks like it's a reflection over the x-axis of the sine curve, because the sine curve starts at 0, 0. So I think this is C, which leaves D for that other one. For number 1, again, midline is at y equals 0, the amplitude is 3, and it does look like a reflection of a cosine because it starts above the x-axis and goes down. I should say it starts below and goes up, but normally it would start up here and go down, so it has reflected the cosine function. So this is D. All right, good luck on the homework. Tonight you're going to do lesson 3.1. If you want to watch any other videos, here's a couple good options.